Yes, hello folks. We are coming with this new exercise. It's exercise 5.7 and we are taking our part 1 video. Now this time what we are doing is we are taking the second derivative. Like all this time we were taking the derivative of a given function once. Now here we will be taking it twice. And that's how it is. So they find the second derivative. That's a question. So whatever is given to us, we will take the derivative twice and that's going to be our answer. So that's what we are going to do it. So nothing great. What we were doing once, we are going to do it twice. So that's how our work is going to be. So let's start right away. We are having this given function. Let's call it as y. Let y be equal to this, whatever that is given to us. Right away, let's take the derivative. So see, y dash you can call or dy by dx you can call. Okay, it's one and the same, different ways of writing. So you're going to take the derivative of this function x squared plus 3x plus 2. Nothing new to us. We know that we are going to take the derivative of each term. We are now, like by this time we have gathered a lot of speed about doing all this, but still, because this is the first problem, I'll just let you know how it is. From next problem onwards we'll gather speed. So derivative of each of this, derivative of x squared we know is 2x, yeah, and x raised to n minus 1, and 3x we know the 3 comes out. Derivative of x with respect to x is always 1, so that is why we are left with the 3. Derivative of a constant term is 0, so it's plus 0. If you want you can write, if you don't write also it's okay. So this is our first derivative. Now that's not enough, we have to take the second derivative. When you have to take the second derivative, you put 2 dashes, okay, for the second derivative. Or if you want, you can also write it as d squared y by dx squared. Both are correct ways of writing. And in this, what we are going to do, we are going to take the derivative of 2x plus 3. That means what? It is going to be the derivative of 2x plus the derivative of 3. Yeah, 2 will come out. Derivative of x with respect to x is 1. So 2 into 1, 3 is a number, doesn't have a derivative. So that is just 2 now, right? So we have got the derivative of this function. The second derivative is 2. That's all. Okay. Now we have this y raised to x raised to 20. That's our next problem. That also, first let's assume y as 20. Very simple actually as compared to other problems. First derivative y dash is first we will take the derivative of x raised to 20. N x raised to n minus 1, it will become 20 x raised to 19. Yeah, n x raised to n minus 1. We remember. Then the second derivative means again you take the derivative of 20 x raised to 19. We know 20 can come out. So x raised to 19 means it is 19 x raised to 18 and x raised to n minus 1. What will this come to? 380 times x raised to 18. Right. So this is all about the second derivative. Of course, this is because we are beginners, we are doing these simple problems. Later on it will gather momentum and you will have a little more tougher. For the next problem, let's call this as y again. Y equal to x cos x. So product is there. So first derivative, let's take the first derivative. We are taking the product d by dx of x cos x. Product is nothing new to us, we know it. X times derivative of cos x plus cos x times derivative of x. Derivative of cos x is minus sin x and derivative of x with respect to x is 1. So this is our final derivative. Now that's not all. You have to take the derivative of second derivative. For that we take the d by dx of minus x sin x plus cos x. So it is like d by dx of minus x sin x and d by dx of cos x. Okay, so this is again product. So minus x times derivative of sin x plus sin x times derivative of minus x plus derivative of cos x. That's going to be our answer. So minus x, sin x derivative, cos x. Derivative of minus x is going to be 1 because derivative of x is 1. So minus x is going to be minus 1. So like that this will become minus sin x. Why? Because that minus 1 comes from here. Cos x derivative we know is minus sin x. Okay, so I think we can write this as minus x cos x minus 2 sin x. I will also check it. Yeah, why not? Yes, right. So that's about it. Then we have this next problem. So log x. So let's call that as y. And the very first derivative is d by dx of log x. We all know derivative of log x is 1 by x. And then we go to the second derivative, that is derivative of 1 by x. We have learned x raised to minus 1 is minus 1 by x raised to minus 2 or minus 1 by x squared. So this is minus 1 by x squared. That's right. So that's our first derivative and second derivative. Now let's move to the next problem and let's see what they have to say there. In the next problem, I'm very sorry for the gadget problem. Yeah, so let's come back to this function x cube log x. So let's see how we can get the derivative. Let y, we could call it as x cube log x, the product. Same thing as we have done before. So it is y dash becoming x cube d by dx of log x plus log x times d by dx of x cube. So we know derivative of log x is 1 by x, and we know that derivative of x cube is 3x squared. How? Nx raised to n minus 1, by that logic. So that's how you get this derivatives. So what is it coming up here? X squared, because this will get cut, plus 3x squared times log x. It will be judicious to take the x squared out. 1 plus 3 log x, that is y dash. Now you take y double dash. You are taking the derivative of x squared into 1 plus 3 log x. So that is going to be x squared, product rule, 1 plus 3 log x plus 1 plus 3 log x derivative of x squared. So let's check now how this is going to come up. Okay, so check, this is x squared times, so when you're taking the derivative, you have to take the derivative of this and derivative of this. Derivative of 1 is 0, and derivative of 3 log x is 3 times derivative of log x, that is 3 by x, and 1 plus 3 log x as it is, derivative of x squared we all know is 2x nx raised to n minus 1. So finally this is actually only this much, right? So the x can cancel, it will become 3x plus 2x plus 6x log x. So that is 5x plus 6x log x. So you only can take the x out, right? That's about it. Now we move to the next question, that is also a product. So there also we start right away. Let y be e raised to x sin x. We are taking the very first derivative, that is by product rule. So e raised to x derivative of sin 5x plus sin 5x derivative of e raised to x. So e raised to x derivative of sin 5x is 5 cos 5x, and sin 5x, the derivative is e raised to x. You could have e raised to x as an overall thing coming out, 5 cos 5x plus sin 5x. Again, this is not all. You have to take the second derivative, which also goes as a product. So d by dx of 5 cos 5x plus sin 5x and 5 cos 5x plus sin 5x times derivative of e raised to x. Let's check. e raised to x as it is, derivative of both these terms, right? 5 will not contribute. Derivative of cos x is going to be minus 25 sine 5x. How this has come? Because already 5 is there, and cos 5x will have the derivative minus 5 sine 5x, isn't it? So that minus 5 and the already existing 5 will make it minus 25. And here sine 5x has the derivative 5 cos 5x. Here these terms there as it is, 5 cos 5x plus sine 5x, and e raised to x has derivative e raised to x itself. You could have the e raised to x overall coming out, so you can have these terms simplified. Just see here minus 25, here just that much. So it's minus 24 sine 5x. Here it's 5, 10 cos 5x. Now whatever simplification you want to do, you can do, otherwise you can leave it like that, right? So that's about it. There are more problems, with that we are coming in the next video. Thank you.